So in the last video, my camera died when I was trying to make this a 1. I left off saying I was going to multiply that matrix by, what was it, like 5 over 33 to make that guy a 1. So this is what I got right here. This full matrix is what I got after I made that a 1. Just that bottom line changed. So now, my goal is to make those two guys 0 now that I've got that guy a 1. I decided to make it a negative 1 just because I could multiply this guy by positive 4/5 and add it to make that 0 there. So that's what I did, and I waded through a bunch of fractions, and I'll let you wade through them, but that's what happened. So I got this guy, row 1, became 4/5 times row 3 plus row 1, and then it went into my new row 1. So you do that for everybody. So 4/5 times this plus that gave me 1. 4/5 times 0 plus 0 gave me 0. 4/5 times negative 1 plus 4/5 gave me the 0 that I wanted. 4/5 times negative 16 over 33 plus 3/5 gives you 7 over 33. Have fun with that. But it's not so bad, just take it over the side. 4/5 times that plus that gave me that. 4/5 times that plus that gave me that. I did it again for row 2 to make this guy to be a 0. I multiplied this guy by a 5th and added it to that. So my new row 2 becomes 1/5 times the row 3 plus the row 2. So if I do 1/5 times row 3 plus row 2, I don't lose the zeros that I worked so hard to get. So 1/5 times that plus that stays 0. 1/5 times that, it becomes my new row 2. 1/5 times that plus that gives me 1. 1/5 times that plus that gives me the 0. 1/5 times negative 16 over 33 plus 2/5 gives me 10 over 33. 1/5 times negative 2 over 33 plus negative 1/5 gives me that. 1/5 times 5 over 33 plus 0 gives me 1 over 33. And then I just went ahead and made that a 1 by just multiplying that whole bottom row by 1. And so finally, this is what we wanted. That's the identity matrix. So this is the inverse matrix that we worked so hard to get. So now, remember our original problem started off with this matrix equation. This was my original A. This is my A inverse. I went ahead, everybody had a 33 in it, so I went ahead and factored it out of all of them to make it prettier to look at. And so this is my A inverse. So the whole reason I got that is to undo the A matrix is multiplying by that. So to undo what's happening to my variables, I multiply both sides by A inverse. And if you multiply A inverse times A, it gives you the identity matrix. I dare you, try it, it'll work. And if you take the identity matrix and multiply it by XYZ, XYZ maintains its identity, and that's what we've solved for it. So XYZ is going to be the inverse matrix times that answer column there. So all I have to do is do this times that, and I'm done. So I'm going to write 1 over 33, 7, 10, 16, 5, negative 7, 2, 4, 1, negative 5, multiplying that by, oh geez, negative 4, negative 1, 33. All right, so that's going to give me 1 over 33 times, so I'm doing matrix multiplication, rows by columns, so negative 28 minus 5, negative 28 minus 5, and then 4 times 33 is 132, excuse me, so plus 132, and I'll add that later. And then now second row with that will be negative 40 plus 7 plus 33. So negative 40 plus 7 plus 33. And now this guy with that guy is negative 64 minus 2 minus 165. And so adding those guys, you get 99, 0, and negative 231. And if I multiply each one of those by 1 over 33, 99 divided by 33 is 3, 0 divided by 33 is 0, negative 231 divided by 33 is negative 7. So the x is 3, the y is 0, the z is negative 7. just like we knew from the last few times we did it. So this by far is the gnarliest way to do it, and I picked a particularly ugly inverse. I apologize. They're not always going to be that bad for your classes. The teachers usually rig them so they're nicer. But if you can do that, you can do anything. And we've got that answer. There's only one other method I haven't done yet, which is Kramer's rule. I dare you to do that problem with Kramer's rule, and I'll show you how to do it with a different problem in another video. All right.